Understanding diffraction and the double slit experiment. Diffraction is a phenomenon that occurs when waves encounter an obstacle or aperture and bend around it, spreading out or interfering with each other. The double slit experiment is a classic demonstration of diffraction and interference phenomena in which light or other waves pass through two closely spaced slits and produce an interference pattern on a screen. Let's explore these concepts in detail. 1. Diffraction. Diffraction occurs when waves encounter an obstacle or aperture that is comparable in size to the wavelength of the waves. This phenomenon causes the waves to bend around the edges of the obstacle or aperture, leading to the spreading out of the waves. Diffraction can be observed with various types of waves, including light, sound, water, and electromagnetic waves. The extent of diffraction depends on the size of the obstacle or aperture and the wavelength of the waves. Smaller obstacles or shorter wavelengths result in less diffraction, while larger obstacles or longer wavelengths lead to more pronounced diffraction effects. 2. Double slit experiment setup. The double slit experiment is a classic demonstration of both diffraction and interference phenomena. In this experiment, a coherent light source, such as a laser, is directed towards a barrier with two closely spaced slits. The light passes through the slits and illuminates a screen placed behind the barrier. 3. Interference patterns. As the light passes through the slits, it behaves like a wave and diffracts around each slit, creating a series of overlapping wavefronts. These wavefronts interfere with each other when they overlap on the screen, leading to the formation of an interference pattern consisting of bright and dark fringes. The bright fringes, known as interference maxima, occur where the wavefronts reinforce each other, resulting in constructive interference. The dark fringes, known as interference minima, occur where the wavefronts cancel each other out, resulting in destructive interference. 5. Observations and interpretation. The double slit experiment demonstrates several key concepts in wave optics. Diffraction. The bending of light around the edges of the slits leads to the spreading out of the light waves, creating diffraction patterns on the screen. Interference. The overlapping of diffracted waves from the two slits results in interference patterns on the screen, with alternating bright and dark fringes. Wave-particle duality. The interference pattern observed in the double slit experiment suggests that light behaves as a wave. However, the discrete nature of the light quanta, or photons, is also observed in certain experiments, indicating the wave-particle duality of light. Conclusion. In conclusion, the double slit experiment is a classic demonstration of diffraction and interference phenomena in wave optics. By passing light through two closely spaced slits, the experiment produces an interference pattern on a screen, illustrating the wave nature of light. Diffraction and interference are fundamental principles that play a crucial role in understanding the behavior of waves and have applications in various fields, including optics, acoustics, and quantum mechanics.